Okay, so today we're going over the Unit 7 review. We will start with Part A. It says, find the other 5 trigonometric functions if cosecant of theta equals -6 and cosine of theta is less than 0. All right, so we've been using trig identities, so I'll do this using trig identities. All right, it says to find the other 5, so we know that we are going to need to find sine, cosine, tangent, cosecant, secant, and cotangent. All right, they give us cosecant, which is -6. So which is the very easy one to find? Sine, right? So it's obviously -1/6. All right, now on the test, all right, you will have the trigonometric identities in front of you. All right, it's also already been posted on Google Classroom, although it was from a while ago, but you can scroll back and find it. I can move it up to the top before tomorrow's test for those of you at home. All right, but so there's a couple of different identities we could use here. Usually when you only have one to start and you've already used your reciprocal identity, you're going to have to use one of the Pythagorean identities, right? So if you have sine or cosine, I pretty much always just go ahead and use sine squared theta plus cosine squared theta is equal to 1. All right, so I know sine theta. So if sine theta is -1/6, then sine squared theta is -1/6 squared. Of course, I don't know cosine, so I leave it, and still equal to 1. So -1/6 squared is 1/36. So I'll go ahead and change 1 to 36/36. Absolutely. All right, so cosine squared theta is equal to 35/36. So we go ahead and take the square root of both sides, and we get cosine of theta is equal to the square root of 35/6. All right, now, it does tell us up here that cosine of theta is less than 0. So this does have to be negative. All right, so this is negative square root of 35/6. Of course, to find secant, we just go ahead and take the reciprocal of this, all right, which would be -6 over the square root of 35. So to rationalize, we would get -6 square roots of 35/35. All right, so now all we have left are tangent and cotangent. All right, the easiest way I feel to get tangent, all right, is to use our identity when we have everything else, is to use our identity that tangent of theta is equal to sine of theta over cosine of theta. Right, now this isn't the only thing we could have done, right? It wasn't the only thing. This isn't the only thing that we could have done here. There's multiple different ways to go about these, of course, but these are just one. So if you did it a different way, don't concern yourself as long as you got the same things. All right, so we are going to have sine, which is -1/6, over cosine, which is -√35/6. All right, so of course a negative over a negative is positive, so those just cancel each other out. When you have a fraction divided by another fraction and their denominators are the same, the denominators just cancel. So this is 1/√35, which when rationalized is the square root of 35/35. So that's what my tangent will be. Of course, to get our cotangent, we just flip our tangent. However, it's a lot easier to flip it pre-rationalization, right? So if If tangent is 1 over the square root of 35, cotangent is the square root of 35 over 1, or just the square root of 35. So we have now found all of our other trigonometric functions. Using mostly reciprocal identities, we just had to use two others, right? We had to use a Pythagorean, and we used one of our quotient identities. Any questions or concerns over part A? All right. Part B, simplify each expression. All right, so here we are just simplifying trig identities. All right, so here we can go ahead and multiply this out, distribute it, or FOIL it, if you will. All right, if we do that, we are going to get tan squared x, of course, tangent times tangent. Tangent times negative secant is minus tan x secant x. Secant times tangent is positive tan x secant x. And secant times negative secant is negative secant squared x. All right, so of course this minus tan x secant x and this plus tan x secant x, yeah, they just cancel. All right, so we're now left with tan squared x minus secant squared x. All right, now, whenever we have squared trig functions, that should be a hint that we're going to be using Pythagorean identities. All right, our Pythagorean identity that involves tangent and secant is 1 plus tan squared x is equal to secant squared x. All right, so that means that wherever I see a secant squared x, I'm allowed to replace it with 1 plus tan squared x. So I see a secant squared x here. I'm allowed to replace it with 1 plus tan squared x. Do be careful to put it in parentheses when you replace it. Right? That way, if you have a negative or some number out in front of it, you remember to distribute that properly. All right. So I'm going to have to distribute this negative to both of these pieces. So we will get tan squared x minus 1 minus tan squared x. So now tan squared x minus tan squared x simply cancel, and this is just negative 1. All right, now, I guess technically you could have solved for tan squared x and done secant squared x minus 1 and then replaced tan squared x with secant squared x minus 1. You would have ended up with the same thing. Any questions or concerns there? All right, B2. All right, so sometimes, especially when you're not dealing with squared stuff, when you're dealing with squared stuff, typically you want to deal with those Pythagorean identities. But when you're not, oftentimes it helps to put things in terms of sine and cosine. All right, well, this is already sine, so I don't have to mess with it. Cosecant of x is just 1 over sine of x, and then minus sine of x. All right, well, now I'm going to go ahead and distribute this. So when I do that, I will get sine x over sine x minus sine squared x. Well, anything over itself is just 1, correct? So this is 1 minus sine squared x. All right, well, again, now we have a squared trig function, so that should kind of ring a bell that we should look at our Pythagorean. Yeah. All right, so our Pythagorean identity with sine x in it says that sine squared x plus cosine squared x is equal to 1. Well, we want to manipulate it so that one side of our equation looks like this. Well, okay, how about we just subtract sine squared x from both sides? These will cancel, And I'm left with cosine squared x is equal to 1 minus sine squared x. All right, so I know that this whole thing right here is simply equal to cosine squared x. Done. Any questions or concerns over B2? All right. B3. All right, well, we just looked at what 1 minus sine squared x equals, right? This is theta, same difference, all right? So 1 minus sine squared theta is equal to cosine squared theta. So now we get cosine squared theta over cosine theta. All right, well, when you have two cosine thetas up top multiplying each other and one down below, the one down below cancels with one of them up top, and we're just left with cosine of theta. That one was pretty short and sweet. All right, so number 4, cosine cubed theta plus cosine theta times sine squared theta. All right, well, both of these terms have a cosine, so we can factor a cosine theta out. And if we're when we do that, what we're left with is cosine squared theta plus sine squared theta. Well, addition is commutative, which means order does not matter. All right, so cosine squared theta plus sine squared theta is the same thing as sine squared theta plus cosine squared theta. What does that equal? I think somebody said it.
1.
1. All right, so this is cosine of theta times 1, which is obviously just cosine of theta. Any questions or concerns on that section? All right. C, solve each equation on the interval 0 to 2 pi. All right, so we're including 0, not including 2 pi. All right, so we definitely need to be mindful of that. So here, this is a pretty straightforward one. We don't really have to do any work. It just says, okay, where is cosine of x equal to -1? Yeah, all we have to do is look at our unit circle here, all right, and that occurs at pi. And that's it. All right, there's really no work for this, nothing to do. You just look at the unit circle and give your answer. All right, so 2 sine x is equal to the square root of 3. Of course, we always want to isolate the trig function first. So I need to go ahead and divide by 2 first. And we get sine of x is equal to the square root of 3 over 2. All right, do remember that sine is the y coordinate on the unit circle. So if you look at the unit circle, you say, okay, where is my y coordinate? Square root of 3 over 2. That occurs at pi over 3 and 2 pi over 3. Any questions or concerns there? Again, pretty straightforward. All right, secant x plus 2 times tan x minus 1 is equal to 0. All right, now a lot of students make a mistake here. All right, they actually try to multiply this out. All right, it's supposed to be a lot easier than that. All right, a lot of times when we're given an equation, we try to get it factored to help us solve the equation. This is already factored for us. So when we have multiple factors set equal to 0, you set each factor equal to 0 and solve. All right, so of course here I would subtract 2. So secant x is equal to -2. Here I would add 1. Tan x is equal to 1. All right, so of course secant is not on our unit circle, but its reciprocal cosine is. So if secant x is equal to -2, absolutely. All right, so I say, okay, where is cosine? -1/2 on the unit circle. All right, that again, cosine is the x-coordinate, so my x-coordinate is negative 1/2 at 2 pi over 3 and 4 pi over 3. All right, here we're looking for when is tangent of x 1. All right, remember tangent on the unit circle you get by taking the y-coordinate divided by the x-coordinate. So in order for it to be 1, the y-coordinate has to be exactly equal to the x-coordinate. All right, that occurs at pi over 4 and 5 pi over 4, exactly. And we're done. Those are our 4 solutions. All right, here we have sine x plus cosine x is equal to 0. All right, there's a couple of ways that you can do this. All right, I actually think of it as just make it a reasoning problem. All right, you could say, all right, well, here we've got, I would just subtract cosine to both sides and say, okay, where are sine x equal to each other? Where are their values the same but opposites, right? Where one is positive and one is negative. Okay, well, that occurs at 3 pi over 4, because at 3 pi over 4, sine is positive square root of 2 over 2, cosine is negative square root of 2 over 2, all right? And it also occurs at 7 pi over 4, because at 7 pi over 4, sine is negative square root of 2 over 2, and cosine is positive square root of 2 over 2. All right, now, you can also think of it algebraically. All right, I personally don't, but you absolutely can. All right, so if you start kind of here again, right, so if we have sine of x is equal to negative cosine of x, all right, well, how about we just divide both sides by cosine x? All right, so here sine over cosine is tangent, and negative cosine over positive cosine is negative 1. So where is tangent negative 1? Well, again, at 3 pi over 4 and 7 pi over 4. So you can think of it either way you want. Okay. So cosine squared x is equal to 1. Right, of course, to undo a square, we can just take a square root, and we have to do that at both sides. All right, so here we get cosine of x is equal to plus or minus 1. Yep, so x is positive 1 at 0. Cosine of x, rather, is positive 1 at 0 and is negative 1 at pi. And we are done. All right, number 6. All right, now do be mindful that our argument here is something other than just a variable. Right? Do not try to get cute with it and try to do some magic getting rid of it early. You can't. Right? That's by far the most common mistake that's made. Right? So of course, first we're going to want to add 1 to both sides and then divide both sides by 2. So sine of 3x is going to equal 1/2. Right now, you need to ask yourself, where is sine 1/2? Don't worry about this 3x at all. Just say, where is sine 1/2? All right, well, sine is 1/2 at pi over 6, and it's also 1/2 at 5 pi over 6. All right, but normally we would just say x equals here. Well, now we don't just have an x, we have a 3x. So we say 3x equals. Okay, well, now that we don't have this 3x with sine, now we can actually do something about it. So I can go ahead and divide by 3. Of course, dividing by 3 is the same as multiplying by 1/3. All right, so now this will give us that x is equal to pi over 18 and x is equal to 5 pi. over 18. All right, now we do have to be careful here, right? Because when you have a number in front of the variable here, this is our b, remember, from when we did our graphing trig functions. All right, so remember that our period, which is how often our answers will repeat themselves, is equal to 2 pi over b, which in this case is 3. You'll miss solutions if you don't, right? Because there's a lot more solutions than just these two, all right? So now, of course, we need to get a common denominator, so this would just be 12 pi over 18. So my solutions will repeat themselves every 12 pi over 18. Right? So if I add 12 pi over 18, I get 13 pi over 18. Now,
how do we get 12 pi over 18?
Our period is 2 pi over 3.
Yeah.
And in order to add it to my solution, I have to get a common denominator. That common denominator is going to be 18.
Right.
Okay. So in order to get this to be 18, my 3, I had to multiply it by 6, which means I have to multiply my numerator by 6 as well.
Okay,
So,
I thought you were doing 2 pi over 13 times 12 like that.
No, we're adding. Right. Just like when we find coterminal angles, we always added 2 pi or added 360. It's the same concept here. We just have a different period. All right, now remember our directions, all right, at the beginning, which you can still easily see them on your review sheet, although there are multiple slides back now. All right, said that we're looking for all solutions between 0 and 2 pi. Is 13 pi over 18 still between 0 and 2 pi? Yeah, sure is, because 13 over 18 is between 0 and 2. All right, so let's see if I can add 12 pi over 18 again. Well, if I do, I get 25 pi over 18. Is that still between 0 and 2 pi? Yes, because 25 over 18 is still between 0 and 2. If I try to add it again, I get 37 pi over 18. That is too big, because 36 over 18 is 2, right? So anything that's that big or larger is too big for us. I can do the same thing down here. When I add 12 pi over 18, I will get 17 pi over 18, which is still fine. If I do it again, I will get 29 pi over 18, which again is still fine. If I tried again, I would get 41 pi over 18, which would be too big. All right, so these are all of our solutions between 0 and 2 pi. All right, so do be mindful, that if your period changes, you have to see if you can continue to add solutions where you need them. Okay, so here we have a quadratic looking type function. All right, do remember that if you don't like quadratic looking functions with trig functions inside of them, you could just say, okay, well, u is equal to sine of x, all right, which means u squared would equal sine squared of x. So you could replace this and say, oh, this is just 2u squared minus 3u plus 1. All right, you don't have to do this. Like if you just see this nicely as a quadratic and you can do it without it, then don't worry about it. But some of you may need to make it look a little cleaner and neater before you can deal with it. All right, so here we have a leading coefficient other than 1. So I'm going to go ahead and do my trash can method here. So 2 times 1 is 2. My b is negative 3. So I need two numbers that multiply together to give me 2 and add together to give me negative 3. Those are negative 2 and negative 1. So I keep my leading coefficient here, and I say 2u minus 2 and 2u minus 1. I do be mindful that when you're factoring, these other u's here are not squared. Lots of students like to try to keep those as squared, but obviously that won't work for the factoring part. All right, since our leading coefficient was other than 1, I'm going to need to take out some trash. So in this case, in this first factor here, I can pull out a 2, and I'm left with u minus 1. Here I can't pull out anything, so it stays 2u minus 1, and I throw away whatever trash I pulled out. So this is now my factorization. You can go ahead and put your sine x back in for the u's now if you want, or you can actually just go ahead and set each one equal to 0 and solve, right? So here u would equal 1, and here u would equal 1/2. And then now you could go ahead and substitute in. So sine of x is equal to 1, and sine of x is equal to 1/2. So again, this is just unit circle stuff. So where is my y coordinate 1? Well, that occurs at pi over 2. Where is my y coordinate 1/2? That occurs at pi over 6 and 5 pi over 6. Again, just looking at your unit circle. Questions or concerns there? We've seen a lot of those on our practice quizzes and quizzes from last week. All right, number 8. All right, we do have a cosine squared here. All right, so we're definitely going to want to set it equal to 0 typically. So 2 cosine squared x, we subtract cosine from both sides, and that gives us equal to 0. But now I can go ahead and factor out a cosine x, and I'm left with 2 cosine x minus 1. Now that I have two factors set equal to 0, I can set each factor equal to 0 and solve. Right, cosine is equal to 0 at pi over 2 and 3 pi over 2. And cosine is equal to 1/2 at pi over 3 and 5 pi over 3. Any questions or concerns over that section? Okay. So our next section is similar, right? We're still solving trigonometric equations, right? But now it wants us to find all solutions. So that's when we have to find that general solution where we say we just find the solutions that we would normally find and say plus or minus n times the period. Okay, that's really the only difference here. In fact, sometimes it's easier because you don't have to find a bunch of different solutions. You just find the one for each thing, or sometimes it's two, and then add plus or minus n pi, or n times the period. Okay, so here, again, we have this 2x, but don't get cute. Don't try to magically undo it somehow. All right, just ask yourself, where is cosine negative square root of 2 over 2? And that occurs at 3 pi over 4, and it occurs at 5 pi over 4. Right, and of course, that's 2x. All right, so of course I can divide both sides by 2 here to get my x's by itself. Dividing by 2 is the same as multiplying by 1/2. All right, so now I know that this is 3 pi over 8. I should say x equals, and x equals 5 pi over 8. Okay, now because we did have some number in front of our variable here in the argument, right, we have to do that period again. All right, for cosine, period is equal to 2 pi over b. My b in this case is 2. So my period is just pi. All right, so all we have to do is say, okay, well, 3 pi over 8 plus or minus n times my period of pi, and plus or minus n times my period of pi. And we're done. This will cover all of our solutions. So in some respects, it's easier than finding the solutions between 0 and 2 pi because I don't have to keep adding my period and check to see if it's between 0 and 2 pi. I just kind of knock out the infinite solutions that there will be. All right, so same concept here. All right, don't bother about this 2 here. All right, I can't stress this enough. You cannot multiply this by 2, right? Like that's not how the trig functions work. All right. Well, right, but to undo it, students try to multiply it by 2, right? You cannot do that. All right. But yes, this is the same thing as sine of 1/2 x. All right. Again, don't mess with this 1/2 while it's still attached to the sine. All right, just ask yourself, where is sine negative 1/2? All right, and that occurs at, let's see, 5 pi over 7 pi over 6. Yeah, yeah. All right, and then of course this is 1/2 x instead of just our regular x. Now you can go ahead and multiply everything by 2. All right, so when we do that, here our x will equal, this would be 14 pi over 6, which reduces to 7 pi over 3. And this would be 22 pi over 6, which reduces to 11 pi over 3. All right, so now we do need to mess with our period. This is sine. So our period, again, is 2 pi over b. All right, a lot of you are still terrible at dividing by fractions, which I noticed on your last test. All right, like instead of multiplying by 2, you multiply by 1/2. Right? Dividing by 1/2 and multiplying by 1/2 are not the same thing at all. In fact, they are exact opposites, right? Like, so when you're dividing by 1/2, don't try to multiply the top by 1/2. That's ridiculous, right? If you're gonna remember your middle school stuff, it's keep, change, flip. Like you have to flip the bottom, right? And you have to multiply. All right, so this just ends up being 4 pi. So all we have to do here is plus or minus 4n pi. Plus or minus 4n pi. Doesn't matter how you write it. That's just kind of proper mathematical notation where you write the constant first and then your variable and your special symbols. All right, but if you wrote 4 pi n or n 4 pi, it doesn't matter. Multiplication is commutative, right? So the order in which you write them doesn't really matter. All right, do be mindful that sine and cosine, the period is 2 pi over b, but if you're dealing with tangent, it's just pi over b. Okay, so that one is a little different. It's possible. Right? I would expect you to know that the period of tangent is pi over b. Yeah. Yeah. All right, so here again, we have just another quadratic looking thing. All right, I'm not going to replace it with the u's this time for those of you that don't do that so that you kind of can see it the way that you're used to seeing it. So again, this has a leading coefficient other than 1, so I'm going to do my trash can method. So a times c, 2 times 1 is 2, and my middle here is 3. So this is going to be 2 and 1, right? 2 times 1 is 2, 2 plus 1 is 3, right? So this is going to be 2 cosine x plus 2. I have to keep this leading coefficient, remember, and 2 cosine x plus 1. Do remember that the squared is not here anymore. I can't emphasize that enough. All right, of course, this is our trash can method, so I have to pull out any trash that I can. I can pull out a 2 here. I can't pull anything out here. So I throw away my trash. Set each of these equal to 0 and solve. So cosine of x will equal negative 1. And here cosine of x will equal negative 1/2. All right, cosine of x is equal to negative 1 at pi. All right, cosine of x is equal to negative 1/2. All right, at 2 pi over 3 and at 4 pi over 3. All right, again, we're still trying to find all solutions. Here we have just cosine x and cosine x. So my period again is 2 pi, right? So this is going to be plus or minus 2n pi. Plus or minus 2n pi and plus or minus 2n pi. So there are all of our solutions. Questions or concerns there? Sure. Yep. Okay.
Wait, so for the period for that one, I was 2?
2 pi, right? Because it's 2 pi over b, but for my x, what's the number in front of my x here? Nothing, so it's 1, right? So this would just be 2 pi over 1, which is how we got 2 pi. Cool beans? Okay. So here we have one where we have two different trig functions, all right? One being squared, one not. All right, whenever this is the case, you will always be changing the squared one, always, okay? And you're going to be using a Pythagorean identity. In this case, the Pythagorean identity that involves sine squared is sine squared, in this case, t, plus cosine squared t is equal to 1. So if I want to replace sine squared t, then I need to solve for it. So I need to subtract cosine squared t from both sides. And you get sine squared t is equal to 1 minus cosine squared t. All right, so wherever I see a sine squared t, I can replace it with 1 minus cosine squared t. So I have a 2. Instead of sine squared t, I will replace it with 1 minus cosine squared t. Do make sure you put that in parentheses because you do need to distribute that 2. And then we will have minus 3 cosine t is equal to 0. So I will distribute this, and I get 2 minus 2 cosine squared t minus 3 cosine t is equal to 0. Writing it in standard form, negative 2 cosine squared t minus 3 cosine t plus 2 is equal to 0. I do not like negative leading coefficients. Some of you might, doesn't matter, all right? You still can factor it with negative leading coefficients. That's just not how I roll. So I'm going to go ahead and multiply both sides of my equation by negative 1. So that will change every sign over here. So this will become positive 2 cosine squared theta plus 3 cosine t, all right, minus 2. And of course, 0 times negative 1 is still 0. All right, so now I can do my trash can method here. 2 times negative 2 is negative 4, and my b is 3. So I need two numbers that multiply together to give me negative 4 and add together to give me 3. All right, that's going to be 4 and negative 1. All right, so I keep my 2 here, so I'm going to have 2 cosine t plus 4 and 2 cosine t minus 1. All right, this is the trash can method, so I need to pull out any extra trash. I can pull out a 2 here, and I'm left with cosine t plus 2. Can't pull anything out here, so 2 cosine t minus 1. I throw this away. I set each factor equal to 0 and solve. So here I will get cosine of t is equal to negative 2. And here I will get cosine of t is equal to positive 1/2. All right, now the range for cosine and sine is from negative 1 to 1. Is negative 2 between negative 1 and 1? No. So from this piece, there are no solutions. All right, from this piece, all right, cosine is equal to 1/2 at pi over 3, and 5 pi over 3. So these are our only two solutions that we care about. What do you mean? No, because I believe. Oh, we still. Oh, that. Yeah, you're absolutely right. We do. I thought we were done with that section. Apparently. Oh, whoops. Oh, did I skip one? Oh no, right here. Okay, so yes, we definitely need to do that other stuff. All right. Plus 2 and pi. Yeah. All right. So here we will say. All right, we will say pi over 3 plus or minus 2n pi, and t will equal 5 pi over 3 plus or minus 2n pi. And again, because there's no multiplier in front of my t, my period is just 2 pi over 1, which is 2 pi. Questions or concerns there? All right, part E. Find the exact value of each of the following. Okay, well, this looks a lot like 2 times sine u cosine u. All right, we just talked about the double angle formulas recently. All right, that was the last section that we did. All right, so this is actually equal to sine of 2 times u. All right, so what's my u in this particular problem? 15. So this is equal to sine of 2 times 15 degrees, which is equal to the sine of 30 degrees. So you just look at the unit circle and say, oh, that's 1/2. And we're done. Good times? Had by somebody somewhere? So we're just really going backwards from our double angle formulas here. All right. Here, this is very similar. This looks a lot like cosine u cosine v plus sine u sine v. Well, that's from our sum and difference formulas. That is equal to the cosine of u minus v. Right? My u in this case is 115. My v in this case is 85. So this is just equal to the cosine of 115 degrees minus 85 degrees, which is equal to the cosine of 30 degrees, which, looking at our unit circle, is the square root of 3 over 2. Of course, you don't have to write this piece down. Same thing in the last problem. I'm just writing it down to show you exactly how I get from here to here, solely for explanation purposes. All right, but you wouldn't have to show this as far as your work is concerned. Everybody good there? All right. So again, very similar. This looks like sine u cosine v plus cosine u sine v. All right, and that is equal to the sine of u plus v. So this is equal to the sine of 80 plus 10, which is equal to the sine of 90 degrees. Exactly. right, and one more like this. All right, this looks a lot like tan of u plus the tan of v over 1 minus tan u times tan v. And this is equal to tangent of u plus v. All right, so this is equal to the tangent of 25 plus 20, which is equal to the tangent of 45 degrees, which is just 1. All right, and now to the calculator part. All right, so here, all right, these are the sum and difference formulas that we just talked about, right? So the sine of u minus v is going to equal sine u, and let me, since we don't have quite as much room here. All right, so this will equal sine u cosine v minus cosine u sine v. This one down here will equal cosine u cosine v minus sine u sine v. And this one will equal tan u plus tan v over 1 minus tan u times tan v. All right, so we're going to need sine u, cosine u, tangent u, sine v, cosine v, tangent v. Okay, and we have to do that from what they give us up here. All right, so first they tell us that the sine of u is 11 over 61. All right, and that u is between pi over 2 and pi. That means I'm in the second quadrant. All right, sine, of course, is opposite over hypotenuse. All right, you can use the Pythagorean theorem, a squared plus b squared equals c squared. I believe this is 60. Is this 60?
Yep.
All right, and it'll be negative because we're going to the left here. Okay, so we know sine u. All right, now I can use SOHCAHTOA to know that cosine of u is adjacent over hypotenuse. So negative 60 over 61. And tangent of u is opposite over adjacent, so negative 11 over 60. Okay, now I need to do the same thing with v. All right, it tells me that v is between pi and 3 pi over 2, which means I am in the third quadrant. All right, cosine, of course, is adjacent, and this is negative since we're going to the left, over hypotenuse. All right, this is also a Pythagorean triple. What is this, like 17? What is this one? Anybody? What is it? 9? Okay. I knew it was a Pythagorean triple. I just couldn't remember which one it was. Okay, and of course this will be negative also because we're coming down. All right, so we know cosine, so we need sine of v. All right, sine, of course, will be opposite over hypotenuse, so negative 9 over 41. And we will need tangent of v, which will be opposite over adjacent, so that will be 9 over 40. Okay, so from here, we simply plug everything into these formulas. Right, now we have all of them. Now, please, please, please do not make the mistake that I'm not kidding you, almost a quarter of every class makes. Right, almost 25% of every class makes this mistake. When they go to plug things in here, They say, oh, sine of u is 1161. They, they say, oh, this must be sine of 11 over 61. No, no, no. That is ungodly wrong. Okay? Remember, in math, when two things are equal, they are interchangeable. So the whole sine of u, this doesn't say u equals 11 over 61. This says sine of u is equal 11 over 61, which means I replace the entire sine of u with 11 over 61. I replace the entire cosine of v with negative 40 over 41. I have a minus. I replace the entire cosine of u with negative 60 over 61, and I replace the entire sine of v with negative 9 over 41. All right, now we can simply plug this into our calculator. All right, so we're going to have 11 over 61, all right, times negative 40 over 41 minus negative 60 over 61 times negative 9 over 41. All right, so we get negative 991 over 2501. So negative, what was it, 991 over 2501?
How did yours come up as a fraction? Because mine always comes up as a fraction.
The one on your phone always does.
I did on the network over there. Will that come up as a?
If you do it on the calculators that I have, if you use the fraction command, it will.
How do I do that?
Alpha y equals enter. Okay, now you don't know, like if you want to be faster about it, all right, you could absolutely say, okay, 11 divided by 61 times negative 40 over 41 minus negative 60 over 61 times negative 9 over 41. Right? I just typed that in way faster. All right. But if you want the fraction, you can just hit math and then this first command that says to fraction, answer to fraction. Bam. Oh, whoa. Why did I mess that up? Did I type something in wrong? 11 over 6. Oh, yeah, I messed this one up. Oh, see, this one actually is right. This one is wrong because this was supposed to be 41.
Yeah, that's probably because I got 980.
Yeah, that should be 41. So, yes, negative 980. On the phone, no. It doesn't matter anyway. You're not allowed to use your phone in my class anyway. Like when we're in the classroom taking a test, if I see you out with a phone, you just get a 0 inch. You're going to be using one of those. So you're not going to have to worry about that on the test. So this will be 980. Bam. All right. And for time purposes, I'm not going to go through every single, like all of the numbers are here, right? This is simply just plugging stuff into a calculator and hitting enter. I'm not necessarily going to take the time to do that a bazillion other times. Okay. Is everybody okay with just plugging stuff into a calculator here? Okay. Really, the work is doing your triangles and getting your sine, cosine, and tangent of of both u and v, right? This is just menial, plug stuff into a calculator and hit enter. Okay, so here, use a calculator to solve each equation on the interval 0 to 2 pi. approximate any solutions to 3 decimal places. All right, so these are really easy. All right, this is just straight, let your calculator do all the work. All right, so what you want to do is you're going to graph these things. You're going to say, okay, y equals, in y1, you're going to put what's on one side of the equation. Now, do be careful because there's no cosine squared button. So what you have to do is actually put in parentheses cosine x, close the parentheses for the argument, close the parentheses for the cosine, and then square it. Okay, that's the only way to put in a squared trig function into your calculator. Okay, and then in y2, you put the other side of your equals sign. So 4 cosine x minus 1. And do make sure that you close that parentheses before you put the minus 1, or it will assume that it's cosine x in parentheses minus 1. All right. Now, we do want to be careful here. We want to go to our window. It said we only care about solutions between 0 and 2 pi. So put your x's between 0 and 2 pi. All right. Now, 4 cosine x is going to go, because it's going to have an amplitude of 4, it's going to go between -4 and 4. So you're definitely going to want to go, somewhere a little bit higher than that just to see. All right. Now we can graph. All right, well, how many places are these functions equal to each other? 2 times, right? And we find those by hitting second trace. We go down to the 5th option, intersect. All right, you just simply move your cursor to the first place where it looks like they intersect and hit enter 3 times. 1.274. So x equals 1.274. We only care about the x's in this case when we solve, right? When we solve equations, we typically just say x equals. If you gave me an ordered pair, I would accept it, but we really are only looking for the x's. All right. We can do that again. Second trace, 5 for intersect. This time I scroll over to the other point of intersection. Hit enter 3 times. 5.010. Right? Again, do make sure that you people know how to round. I've seen people round stuff like this in really, really crazy ways. All right? This 9 is essentially rounding up to a 10. So this becomes a 1, this becomes a 0. It's not that difficult, right? But for some reason, a significant chunk of you people have no idea how to round, which is very, very distressing in honors pre-calculus. Right? I could understand that in like algebra 1, but not honors pre-calculus. All right, so we can also go ahead and do this other one over here. Do it the same way. All right, go to our y equals. We can say sine of 0.5x in y1 and 3 times cosine of 1.5x. No squareds there, we like that. All right, so we can go ahead and graph this again. All right, now we're going to have 1, 2, 3 points of intersection. Now, guys, if you leave your window -10 to 10, you're going to have like 7 or 8 points of intersection. Like that should be an alarm that you're probably not looking in the right spot window-wise, right? All of it says between 0 and 2 pi. All right, what do we estimate pi to be? 3.14. So all of your answers should be between 0 and 6.28. So if you start throwing me all sorts of negatives and numbers bigger than 6.28, obviously you're doing it incorrectly. Okay, so here we can second trace 5. I always go from left to right. Bam, bam, bam. All right, so 0.946. We can do it again. Second trace 5. 3.367. And we can do it one more time. 5.113. And we're done. Right, so for these ones, it's just answers, right? Your calculator will get them for you. And we're done. Questions or concerns there? All right, do make sure you do second trace, right? If you just hit the trace button and try to use and you're like, yeah, that's pretty good. That would be 3.380. Nope, you're not going to get that, right? You would be wrong. Okay, your calculator can be much more precise than that. So please allow your calculator to be much more precise than that. All right. All right, given sine of u equals 15 over 17, and that u is between pi over 2 and pi, find the exact value of each of the following. All right, so cosine of 2u, we have three different equations, and you can use any of them. I'm very partial to cosine squared u minus 1. Or I'm sorry, that's 2 cosine squared u minus 1. You also could use 1 minus sine square, or 1 minus 2 sine squared u. You also could use cosine squared u minus sine squared u. All right, sine of 2u is equal to 2. Whoops, it really matters since it's multiplication, but 2 sine u cosine u, and tangent of 2u is equal to 2 tan u over 1 minus tan squared u. All right, so these are the formulas, are double angle formulas. They'll all be given to you on our formula sheet. All right, but we need to find sine u, cosine u, and tangent u. Of course, we're given sine of u. All right, so now we just have to do, it tells us that our angle is between pi over 2 and pi. So we are in the second quadrant. All right, sine is opposite over hypotenuse. All right, so this should be 8, correct? Anybody who's already done it? And of course, it'll be negative because we're going to the left. All right, so cosine of u is equal to adjacent over hypotenuse, so negative 8 over 17. And tangent of u is equal to opposite over adjacent, so negative 15 over 8. So now again, just like we did with the sum and difference formulas, we just plug these things in. All right, so this is going to be 2 times cosine u is negative 8/17, so negative 8/17 squared minus 1. All right, this would be 2 times 15 over 17 times negative 8 over 17. All right, and this one would equal 2 times negative 15/8 over 1 minus negative 15/8 squared. All right, so again, this is all just super calculator stuff, right? So we can say, all right, 2 times. And again, if you use this fraction command, it'll just automatically give you an answer in fraction form. Whoops, no. All right, so you plug that in, bam, we get negative 161 over 289. All right, for this next one, we get 2 times 15 over 17 times negative 8 over 17. All right, now if you do this, it'll just give you that decimal. But if you hit math, enter, enter, negative 240 over 89. And last but not least, this absolute disaster up top. All right, so we have 2 times negative 15 eighths over 1 minus negative 15 eighths squared. All right, so bam, 240 over 161. Whoa. And we're done with those. All right, so any questions over those? Hopefully we've had lots of practice at making these triangles by this point, right? This is our like 4th trig unit. We've been making triangles for at least 3 of them. All right, so if you can't do SOHCAHTOA by now, I highly suggest you brush up on SOHCAHTOA. Of course, you're probably not doing very well if you don't know SOHCAHTOA by now. All right, so part I, use the trigonometric solution, x is equal to 6 sine theta, to write the expression, and this should be the square root, of 36 minus x squared as a trigonometric function of theta, where theta is between 0 and pi over 2. You don't really have to worry about this part. It's just saying make it a first quadrant angle so it works out really nice. All right, well, of course, whenever two things are equal, they are interchangeable. So I'm going to rewrite 36 minus x squared, but instead of x, I'm going to write 6 sine theta. And that whole thing is squared. Because it told me to replace x with 6 sine theta, right? All right, so 6 sine theta, guys, don't just write 6 sine squared theta. It's not. A lot of you did that on the last test with lots of things. All right, you have to square the whole thing. Remember, when you square something, it's being multiplied by itself. 6 sine theta times 6 sine theta, all right, is 36 sine squared theta. All right, again, remember, you cannot just take the square root of both pieces from here. That does not work with addition and subtraction. It only works with multiplication and division. So what I have to do here is factor out a 36. And then I'm left with 1 minus sine squared theta. All right, well, from our Pythagorean identities, what do we know 1 minus sine squared theta equals? Cosine squared theta. All right, so this now just becomes 36 cosine squared theta. Oh, hey, what do you know? Now there's no pesky addition or subtraction in there preventing me from just taking the square root of both pieces, so I can. The square root of 36 is 6. The square root of cosine squared theta is cosine theta. And we are done. And that is it, yes? All right, any questions or concerns?